are all set and ready to go. So thank you everyone for joining. My name is Nathan Piccini. I am one of the marketing managers here at Data Science Dojo, and we are really excited to have Sambeat Das with us today. He's going to be presenting, how to build a personalized attrition recommendation system. And Sambeat he's a data science and AI instructor with 17 plus years of consulting in HR transformation and system implementation. So Sambeat, why don't you go ahead and then, well, actually, before you get started, I should announce if you have questions, we're going to be taking them all at the end. So please use the Q&A tab so that we can, help us sort those questions out. And you can upvote questions that have been asked. So if you have a question that's already been asked or a similar question, give a question and upvote, and we can make sure to answer the most popular questions first. So with that, Sambeat, why don't you go ahead?
All right. Thank you, Nathan. Welcome, everyone. And thank you for joining this session. I'm really excited for this session. My name is Sambeat. I'm based in Australia, and I work as a data scientist here in Axiona. And apart from my full-time job, I'm an AI researcher. I like to speak in conferences, and I'm also teaching in one of the universities here in the evenings. So that's me. All right. So for this session, as we have spoken about, or we have mentioned in our agenda, I am going to go through an attrition recommendation system, and my idea is to break it down into step-by-step method, as a step-by-step process, so that I can show you how I went about creating this model. I would not probably go into the technical coding in this session, but I'm happy to take any questions later on. But what I want to show you is the data science methodology that I have used, and the exploratory data analysis. I'll also give you an idea of the app. So I'll show you the app that I've built at the end of the session as well. And hopefully we can share the link also of the app with all of you, so you can also play around at the end of the session. So, all right, let's kick it off. So this is the basically the agenda for my session. I'm going to talk about the business case first, because I believe we need to start with a business problem first before we start doing analytical work. So that is how I approach my analytics projects. I try to break down and understand what the business problem is. So that will be the first step. So we'll break down what are the problems we are going to solve in our machine learning deployment. The second step is to identify the hypothesis. So what is basically the statistical statement that we are going to prove or disapprove through our work. I will give you an idea or an overview of the data set. So the data set for attrition project is something that is publicly available, and that is the data set is published by IBM, and that's called IBM attrition data set. It is freely available in Google. If you do a Google search, it's also available in Kaggle and other platforms. So we'll take a look at the data set. I will go take you through some of the ADA steps that I've done. So ADA stands for Exploratory Data Analysis, and that will be the first step of our modeling work, where I will show you some of the correlation analysis and descriptive analytics that I did on the data set. We will then move into predictive modeling approaches. So again, I'll give you a high level overview of what kind of modeling work was involved in this development. Now, predicting attrition or in an organization is fine. That's fine. That is one step. But I wanted to go a little bit beyond that. I wanted to develop the prescriptive side of the app. And for that, I'm going to touch on the recommendation. So what recommendation means is, if we highlight that one person who is active right now in the organization is at risk of leaving because of parameters and variables that we think are high predictors of attrition. What should the business do, or the HR or the business or the manager do to retain that employee, right? So that is the recommendation. So the app should also be able to give recommendation to support decision making, to help retain the person, not just only predict this person is likely to leave. So we want to go into the prescriptive stage. So I will explain how I developed this. The last two steps basically is step 7 is the change management, which is basically how do we go about driving adoption of analytical projects. The step 8 is the attrition predictor app that I've developed. So I'll take you through that app. And then the last thing is basically deploying, how did I go about deploying it? So I'll give you an overview of that, and then we'll take in any questions. Okay. All right. So how do I go about developing or working on an analytical project? I break it down into these 8 steps. And this is basically how we just went through the agenda. The agenda is also organized in these steps. So the first thing we want to understand is why we are undertaking any analytical project. So in this case, why did we go about doing an attrition study? So what are the business questions we are trying to solve, and what is our hypothesis? This is step 1 and 2. The next stage is how should the project be carried out? So in this case, we want to identify the data sources. We want to also identify the data fields, develop a data dictionary if it is not available, so that you understand these are the variables and these fields are meant for doing what. So you understand the data. Then you start doing and then you start doing the exploratory data analysis, which is step 4. And then from the descriptive or the exploratory data analysis, you can already start revealing insights through correlation analysis, which means basically we can see that for people leaving is a certain age group likely having higher attrition than or a department or any such variables that are showing high attrition in comparison to others. So we want to do what we call in our data science is univariate or multivariate analysis, which is like analyzing variables and doing correlation analysis. And then we start in step 6. In step 5, after we do EDA, we also go into a modeling work, which I will be showing you around the predictive modeling part. And then we develop recommendations in step 6, which is another Excel based strategy that I've created. So we will go through that and see how we can develop recommendations for predictors, which are highly likely to predict attrition. The last stage is what will result from the project. So exactly, so this is where we want to understand how do we drive adoption, what's the role of a change sponsor, and also how do we implement and evaluate the model. So how frequently should we evaluate whether the model is accurately or how efficiently the attrition model is helping the organization save cost or retain staff. How do we go about evaluating that? So that's basically the 8-step process. This is taken or inspired by Jonathan Ferrer's book, which is called The Power of People. And he's a respected consultant and a speaker, an author in HR strategy. So I've studied his book, and I've taken his methodology and used it in my project. Okay, so step 1, we want to understand the business question, okay, for our project. So in our case, I want to study, first of all, the financial impact of attrition. So if people leave, what is the cost to the company? So I want to quantify that, because that is where I want to define the ROI. So if through our work, we can show that after 6 months or so, that we can save X amount of dollars for the company, then that's a definite ROI, right? So we want to start off understanding what is the trying to quantify the problem. That's why we want to understand the financial impact of attrition. I will show you a calculator that I've been working on, and that will help to understand and identify the financial impact of attrition. Okay, so then we will do uh, EDA and modeling to understand the business problem where proportion of staff is leaving, and what is the proportion of staff leaving, and what is the variance with time. Are they increasing with time? Are they decreasing with time? What are the factors that are supporting attrition? So we want to understand that. The company wants to understand that. Is it distance from home? Is it salary? Is it manager? What are the factors that are supporting high attrition? And then hopefully from that knowledge, the company also wants to understand what business decisions they can take to retain high performing staff, right? So that these are the business problems the company wants to explore through our data modeling work. Okay. Right. So we are now covered step. We have covered step one. So let's cover the next step, which is step two. In this case, setting up hypothesis. Now you may think, what is hypothesis? Hypotheses are basically statistical statements that are basically kind of problem statements. We use that to then start working on the modeling. So we want to start with a hypothesis here, and in this case, we are saying that there are no predictors, significant predictors that exist for attrition. So we are basically saying the null hypothesis that is our going in position is that none of the factors like salary, manager, or any other department or any other such variables have any role to play on attrition. People leaving are the same across the company, across all departments, and that is basically a very healthy attrition rate happening in the company. It is not above the attrition KPI rates in the industry, and everything is kind of normal. Okay, so this is our assumption. The alternative hypothesis is that there is a presence of significant predictors of attrition. So there is pockets inside the company, like a department or a location where there is high attrition. If we are able to prove that the alternative hypothesis is true using our analysis and data modeling work, then we can showcase that yes, this is without a doubt, there is strong proof that we have factors that predict attrition. So this is where we want to start modeling and understanding if there is any evidence. Okay, so that is step two. All right, let's go to the next. So this is the now we'll get into slowly into the data part, and then the analysis and modeling work. So as we have a look now on the slide, this is the IBM attrition data set. So if you do a Google search, you will be able to find this data set. It is freely available, and I've used this for my modeling work. Okay, so this is just an example snapshot of the data set. I have, by the way, for my modeling work, I have used RStudio, but yeah, it can be developed in Python as well. But for my app, I have used RStudio. So you can see there are several variables in this data set. So we have age. Attrition is basically whether this person has left or not. Sorry, the first line is observations. Basically what it means is the number of records in the table. Okay, and so there are 35 potential fields. So we have like different types of variables for the employees. So daily rate is the hourly rate, the department, and then distance from home is calculated based on the office address and the home address of the person. Then what is the education background, employee number, which is not kind of used. The employee number is not of any significance for our modeling. but there are certain variables we will discard. So one of them would be the employer number. However, we will still need it to do a search in the app, which we will develop. So I'll show you that a little later in this presentation. So then again, we have gender, we have job related information, we have marital status, income, number of companies worked, yeah, and performance, and yeah, tenure in the company. So these are the kind of variables that are involved in the data set. So I just wanted to give you an idea what is this data set. Now, the HR data set, unlike any other department data set like finance or sales, this is, I feel, very easy to understand. These are information data about a person, so it's much more easier to understand, I think. And so hopefully you can all get this, and I'm happy to address any questions at the end of the session. So please keep your questions with you. If you have any questions, we'll come back. All right, so again, I started with the EDA now, the exploratory data analysis. So once I do the analysis, I start with exploring how the termination and the hiring process has happened over the past years. This is just a snapshot of a period of time interval between 2014 to 2018. On the left is basically it's showing you the hires over every month. You can see that from the spikes that October, November period is generally where the hires happen on the left-hand chart. And that's why, because the size of the bar is high in the November month, and it is not surprising because the data that I used to do this has a lot of employees from graduate hires, and it's a retail company. So what it means is that they do a lot of hiring in the month of November because it's a holiday period for the retail industry. So there's a lot of requirements for people during the holiday period. The right hand side table is basically it's a chart where it is plotting the hires across several years. So it's another way of visualizing it. Okay. Now we want to understand, when we do attrition basic analytics, I also wanted to understand what is the percentage of attrition for each by department and by job role. And also I want to identify if it is above industry average or not. So for that, I had to go in and this is, again, please keep in mind, this is all test data. So this is not real data. So in this case, I was doing an analysis of what is the industry KPI of attrition for the specific company. So if I identify that normally you should not have more than 10% or 8.8% in this case, I wanted to understand what is the attrition percentage by department and job role for this company. So you can see that we have in sales, the sales representative job role is having a high turnover, and it is, there's a high percentage, and it is actually above industry average. Same goes for human resource, and then there is an R&D development job. Laboratory technician role also has a high attrition, for example. Okay, so this is basically what this table is showing. So again, in the EDA, we have already slowly started to uncover some insights. We can see that sales representative role is one of the highest, has one of the highest attrition. And then the same thing is laboratory technician as well, research scientist. These are some of the roles that have high attrition. We are already seeing that from the initial analysis. So we want to go a little bit further and try to understand, okay, on the left hand side on the chart, you'll see some plots. So the first plot here is, I wanted to understand if length of service has, if people who are leaving, how many years or how many months they have, stayed in the company before they left. So I wanted to analyze that. So what happened here is that the blue line is basically the proportion of active staff in the company. So you can see that generally people are within 0 to 1 year. They are in the company. So they have just joined recently. They have maybe spent most of the staff have spent around a year in the company. So it's a very young staff in that sense, right? But look at the terminations. So attrition is also high on that same range. So what we can see here is that people have recently joined the company, but they are also heavily leaving the company within the first 1.5 year. So clearly this is kind of giving an idea that we'll the company needs to look at the first initial 1 or 2 years of an employee. Why would that occur, that they leave the company so early? Because the company invests a lot of money in training, and so that is a little bit not, yeah, it's not good to have people leaving at within 1 or 1.5 years. So that is interesting. I was also looking at the age. So in this case, the blue color line is basically the active population, and the pink line is the terminated attrition, where the attrition has happened. So we can say that the population of employees who are active in the company, they are generally in the 30-year range, and then the people who are leaving are also in the 20, 27, 28 years of age. So yeah, so attrition is basically happening in that younger age group, and makes sense because the majority of the employee staff members are also in that range. So so we can already see that, yes, so there is that age group that is having higher attrition. Now this part right inside, this is called what we call as correlation analysis, and in R I developed this to understand. Basically I took most of the variables that we saw in the data set. I analyzed it with the attrition variable to understand if any of these factors have a role to play with the attrition. So if there is a positive correlation, then you'll have a plus figure. A stronger correlation is closer to +1, and a stronger negative correlation is closer to -1. That's how we understand and study correlation factors. So again, there was not very clear insights from the correlation analysis here in this case, in this test data, but we will dive into more details in the subsequent slides. Okay, but yeah, this is basically an example of how I went about doing my exploratory data analysis. Of course, there are tons of other stuff that we can do, but for this presentation, I was just showing you a couple of things. Okay. Now, remember, I spoke about cost of attrition, and this is very exciting here. This is where we break down the whole concept of how do we go about measuring the cost of losing good people in the company. Okay, so this is divided into 3 or 4 sections, this cost calculator that I've worked on. The direct cost is basically when someone leaves, then the company has to spend money on advertising the job, spending, sometimes engaging with recruiters. So you have to pay recruiters money so that they can help, when they get a resource for the company, then you pay something to the recruiters. Then there is acquisition, travel related expenses. At times you need to go in and do you need to pay for travel at times for the candidate to come in and do the interviews. If the position is vacant, then you may have to get a temporary assistant or an intern or a contractor for 7-8 days or 10 days, 20 days. Sometimes if it's a critical job, you probably need to look at that. So these are direct costs. So we know every time someone leaves, these costs are probably included by the company. So that's why we call it a direct cost. But we also wanted to understand the indirect, the loss of productivity costs. So what does this mean? So based on the company statements, there is an annual revenue published by the company every year. So what in this case I was doing was I took that revenue data and then equated it for each employee in the organization. So then you know what roughly on an average what each employee is bringing for the company, right? So if you average that, then what you end up is, okay, if I'm contributing an X amount of dollars to this company and I leave, what is the loss of productivity? So if the work days per year is 240, there is 240 working days, average working position open. So if I leave, then my job was basically open for 40 days. And if someone else is coming in my role, then this person is not supposed to be working like, at full capacity level on day one, right? This person is learning, so they will take time to be at fully at par, or at, in terms of knowledge, um, to operate at that level, maybe in 40-50 days or so. So here, for test purpose, we have assumed 60 days, but it can be lesser as well, depending on the role. So how do you and so then in this training period, we have identified that the person will be 50% effective in the training period. This person will not be like 100% effective. So then in using that, we use this calculation that this person will be bringing in X amount of revenue in the training period. They will not be at full capacity, but they will be able to give a dollar figure of productivity, which will be lesser than what I would have probably given in my role before I left. So that is loss of productivity. So, and the other thing is savings. So company also saves. If I leave, then the company is not paying salary for the time the new person has not joined. So there is savings. So in this case, if we have a salary here and this position was open for 40 days, the recruitment process was happening for 40 days, we save money for those 40 days. So this is what basically the dollar value is. And so what is the estimated turnover? The estimated turnover is you add the direct cost, loss of productivity, and then subtract the salary savings. So that's how you end up with a total figure of estimated turnover. And then if you have 200 people leaving in the year, so then you have a turnover cost of X amount of dollars for the company, right? So that's how basically is how I went about calculating the attrition. Okay. Now these numbers, again, the salary figures, the loss of productivity, these are all, um, how do you put it? These are all test data. So please don't take it like, you can just model it on any other company data. It has to be studied and worked with the HR leads and managers to fine tune this calculator, right? So the one thing that may be constant is maybe the annual revenue, which you can go into the company and have a look at. But all these variables will need to be refined and fine tuned with for each company. Okay. So what happens if we are able to identify the cost of attrition using this? The powerful thing is that then we can we can model the cost of attrition by department and by job role, because essentially we have arrived at a figure of every person leaving, what is the cost of attrition, and then this is how you model and put up a dollar figure. So imagine if we present this to the senior management, then we can share that, we have a $7 million problem to solve. So that is more powerful now, to explain, and then get a buy-in, right? So this is again plotted in R, using R, and so this is basically showing the position, the job role, and the department. So here we can see that the sales executive and the library technician, we are potentially losing close to $8 million. So this is the problem for the company. So again, I encourage you to also do this kind of analysis. If you are interested in attrition analysis, you can come and you can do this kind of modeling work. It'll be good. Okay, so this kind of caters to two business problems that we have been talking about. One is understanding the cost of attrition. So we have come to that stage where we can understand the cost of attrition. The second thing is revealing insights and revealing proportion of staff leaving. This is also something we have covered in the EDA part. So let's now dive into the step 5, which is the predictive modeling. Okay, so in my case, I used H2O automated machine learning algorithms, which is basically it runs several machine learning models and selects the best performing machine learning model that provides greater accuracy in predicting attrition. So, but in this slide, I've just picked up one model here. So in this case, the logistic regression model predicted. So in this, so our data set, if you remember, it had around 1200 observations, 1200 records. The idea here is that we divide the training data set, into two parts. One is the training data set. Let's say 80% of the data is in the training data set, and the next data set is the test data set. So we keep it aside. We do not train the model on the test data set. The training data set is used to train the model. So once the model is trained, we then apply the model on the test data set and ask the model to predict what is the status of each and every employee in the test data set, whether this person is likely to leave or is likely to stay. And then we use the model predictions and the actual status, because we know the test data set also has the status of the existing employee, right? So we just match the prediction with the actual result and then find out the accuracy. Okay, so this is how we calculate confusion matrix and statistics, for those of you who are kind of new to this area. So the left hand tab, the model has predicted top 8 factors that are predicting attrition. So people who are working overtime are likely to leave. Job level 1 is a type, basically the numerical value of the type of the job. Then distance from home is also kind of important for predicting attrition. And then there is age, number of company work, and other factors, right? So that's powerful, because we now have a definitive list of variables that are supporting attrition. So remember, the hypothesis we had, a null hypothesis, was that there are no predictors of attrition. I think we are coming close now to prove that there are actually significant predictors. And how can I say that we are coming close? Because you can see here that the model has predicted with 84% accuracy the status of the employee on the test data set. So when I use the model to predict the attrition status, whether the person is active or not active on the test data set, like let's say 200 employees, it predicted yes and no, and it was actually correct at 84% accuracy. So that's decent, I would say. There are ways to improve the performance and accuracy of the model, but 84% is start. So prediction is one thing, and I was talking about then what do we do? How do we help the business to identify recommendations and help them retain their staff, right? So that is where we want to start building a recommendation algorithm. So in that case, we would like to understand which factors are supporting attrition and which factors are contributing contradicting or working against attrition. And that is important, because if we know which variable or which factor can help reduce attrition, then we build our recommendation using that knowledge, right? So this is where even though the red variables are ranked and we see that these are the factors that support attrition, we also have these factors where you know that if someone is married, then he or she is not less likely to leave the organization, it looks like, based on the analysis here. So just showing you that the blue the sorry the black color variables here, gray colored, they are all working against attrition, which is good. This is what we want to see. So both of them have been ranked in terms of importance, and we use that then to create strategy groups. So what does this mean? This means that if we have variables that are supporting attrition from our machine learning model, we want to group similar variables into categories. So in this case, overtime, distance from home, frequent business travel variables have been grouped under work life. And I have now, I'm proposing a very high level recommendation here to reduce overtime and manage business travel time. Anyone who falls in this bracket, that they are working overtime, yes, they are staying far away from their home, or they are traveling frequently, will now, if they are highly likely to leave the organization, then HR or business can immediately see that, oh, okay, these are the things we have to look at for this person, because these factors are driving attrition. So we will look at the app very soon, but this is how we go about building the recommendation. I would say that this is still a little bit on the high level. Reducing overtime, yes, okay, but we can even go into more detail and create more specific recommendations using the input from the HR and the managers. Okay, so again, we have other variable categories as well. Years at company, time in role, you group them under professional development, and then job satisfaction and involvement, which is more into personal space, right? So this is how we go about creating the recommendations. This is then moved into a Excel, because so that I was, able to work better on this one. And then I use this to develop the algorithm, which is basically every factor here. And this is the discussion, and this is the potential strategy. If this variable is playing a role in predicting attrition of an active staff member, then we are looking at what is the potential strategy for HR or the company to look at. Again, this is something that needs to be discussed with the management, with the HR and managers, and develop this one. So it's not something that we can just assume and prepare. So this is basically a working sheet of that. Before we go into the app, I wanted to also talk about getting your point across, which is your step 7. What do we do after we have developed the model? So you want a sponsor or sponsors who can help champion this cause. And this is, some of you would already, if you have worked in projects or have been studying in the analytics space, you would know that a lot of projects fail because they do not have leadership support, and people are working in the analytics, but they can't tell their story across. They can't put their story across. Why they are doing it? Why is it important for a manager? Why is it important to look at this insight, right? So that is why change management, training, communication, these are all very, very important. They should not be compromised. So this is where an analytics team is not just a data scientist or a business analyst. You have a group, you have a team. Someone is good in visualization, someone is good in coding, someone is a change sponsor, someone is a project sponsor. All of these people, they form a successful analytics team. This is what my learnings are. Okay, so all right, so I'm excited to show you the app. This app is something that I've created last year, and during evenings after office, and I'm hoping that it's still a prototype, by the way, but I'm hoping you'll understand, and you can play around this app yourself as well. We'll share with you the link shortly. um, so what is this app doing? This app is basically using Shiny apps, which is basically a hosting platform from RStudio. After developing the programs, I public just generated this app using Shiny app. And on the left hand side, I can select the employee number, as I was telling at the start, that you use the employee number to do a search function. So I use the employee number here in the drop down. I select an employee number, and the app will provide whether this person is likely to leave or not, what is the risk of attrition, and what's the job role, department, and some other variables here. And on the right hand side, it will give you the attrition risk, which factors are supporting in blue the person leaving the organization, and which factors in red are not supporting attrition for this person, right? So this is where this chart is going to give that information. Okay, so let's do a play around on this one. So I think we can share the link, Fatima, on the chat to everyone, so that they can also access this soft app. So I'm just refreshing my screen. So usually it takes a little bit time to open. Let's see, we'll try a different browser if it works. Okay, so it does work now. So it's good. So this is the employee number. So maybe I'll search for one employee just to show you one example. So I've just selected one employee. Let's see, it will take again some time to work with the model and then come up with data. So this is a very, like a very basic app that I've created using RStudio, and yeah, so it's something that definitely all of you can also develop if you are interested or you have experience in R. You can go about creating this. So what it does is it will show all the attributes of the employee, and it will also show whether this person is at risk of leaving, and if so, what are the factors that support attrition. Okay, so sorry for the network issue, so it's a bit slow on my side, but yeah, you can see now that the model is predicting that this person is likely to leave the organization, and there's a 58.86% risk that it is predicting. And why it is doing that? Because this person works overtime, is at a job level that is at risk, and is a predictor of attrition. A lot of people in this job level have left in the past. So the model understands that this field is important. The person has worked more than 4 companies, and then the person is also staying more than 13.8 miles from the office, and travels frequently as well. So these are the blue. In the blue, these are the factors that are supporting attrition. That is why this model overall is saying that this person is highly, or not highly, but it is more likely this person is going to leave, because the percentage is not 30%, it is like 58, 60%. So that's why I said it's not like very likely. However, the interesting part here is the recommendation as well. So for this person, because of the variables, you remember how we went through the recommendation sheet. We can also look at, we need to look at improving work-life balance. Why? Because this person is working on overtime quite a lot. So these are the things that model is also showing that this is for the business to look at. Now you can look at this recommendation and say, okay, this maybe is a little bit high level, it is at high level, because that is where we have to go and build that recommendation sheet further into detail, specific details. So this will come up, and recommendation, more specific recommendations to the HR and the managers to look at, right? So this is powerful. This is not most of the work you will see somewhere here. Prediction algorithm, fine, but we would like to go and help the company retain their staff. So this is where this comes in. Again, very basic app that I developed, but hopefully you'll understand this, and hopefully you can play around yourself. Okay, so that is basically all I had to cover for this session. And I'm very happy to take any questions.
So it looks like we do have 2 questions. And if anybody else has questions, feel free to use the Q&A chat. If you're on one of our live streams, please ask your questions. We have team members out there to pull them into Zoom. So Sambi, why don't you open up the Q&A, and then I think we have 2 questions. 3 questions.
Okay, no problem. So we have a question of what is the chart on the left called? Looks interesting. So I'm not sure which chart was being referred to. I'll just cover. So these are basically visuals that we use. This is like a facet plot where different curves and graphs are plotted into facets. This box is like a facet. This is like a circular plot. Again, example codes are available online. And this is like a feature plot. We call this as a feature plot in R. So this is where you have interaction of variables. You can see that. Yeah, okay. That's basically those charts. All right. So how did you set the yes/no cutoff for the prediction outcome produced by the logistic model? Okay, good question. So let's see. So anything that was above 50%, the model, I have not coded specifically that predict yes or no. There is no hard coding involved there. If the model prediction is over 50%, then you have elevated risk prediction factor. You mention that it is above whatever that percentage is, and then it then says that the probability of this person leaving is 0.56%. So in our app, we do not say this person is going to leave yes or no. We are only highlighting the model results. So that's all I wanted to say here, that we are only providing model results here, and there's a probability which is also derived from the model and the variables for those employees. Okay, this part here, I think you are talking about this one is basically overall based on the risk prediction. If it is beyond 50, then you have this, and you may choose not to have that field also. So this is something that can be also hidden. Okay. So how was the estimated cost of attrition calculated? So estimated cost of attrition. So estimated cost of attrition was calculated here. This is the calculator that we have gone through. So this is how I have explained in our chat today, that how did I go about calculating the direct cost, productivity cost, and savings. And so using that, you derive the employee per employee, every employee, how much does the company lose when they lose one person. And if they lose one person, then you use that data and plot the attrition. The numbers, right? Number of people leaving in sales department. This is, let's say, 30 people, and one person leaving, how much company loses. So that's how you do that formula and do a cost of attrition modeling. Okay. Is there any R source code available? Okay, so I do not have R source in the sense that the one that I have built or worked on, I cannot share that because I'm using that for some of my own work as well, and it is still not fully finalized. I do all my research work outside the company. However, you can find course. There is a course which is called data science. 1 second, let me just search that and I'll send it in chat. If you are interested, you should. I actually have taken a lot of inspiration from this course for my work. So it's called business science io.io. So it's the course is from Matt Dancho, and he has a very good attrition course. So he has R codes and everything available in that course, and he goes about calculating the cost of attrition also in his course. So feel free to check that out. Okay. Did you use cross validation to get the best accuracy score of the model? Confusion shows yes, we did. Yeah, and that's correct. So the confusion matrix is showing the cross validation model versus test data. And again, this is, let me see. Yeah, it is probably giving you a high level overview here, but yes, I mean, of course, you can use your same methodology, machine learning methodologies over the training and testing data set to evaluate the model. Good question. What is the recommendation model used to see the positive and negative attributes which is impacting attrition? Okay, so Dibyendu, recommendation model that we used was basically a calculator. So we created a calculator or an Excel sheet, which I call the recommendation sheet, where you have every variable and then you identify recommendations. If that variable is likely a factor for someone to leave or at risk or leaving, what is the recommendation? So I created recommendations at each variable level, and then using that, you already know that the model will predict this will be the model result. So right, so if I apply the model on one person, if that person is likely to leave, the model will say these are the 5 variables that are supporting attrition for this person. And then when I have the underlying recommendations, I bring it into the front for those 5 variables. What are my recommendations for the business? So that is how you go about developing the model. So of course there is coding involved there. So, but it is think about it this way: the recommendation is for every variable, and depending on which variable is supporting attrition for one person, the recommendations will be proposed accordingly. Okay. Would it help to score the recommendation model, saying which one is most important to focus on? Yeah, very good. Absolutely. Yeah. It's a good point. And yeah, I like that actually. So you can definitely, score recommendations. And so this particular sheet can be also, expanded. We can have recommendation scores, and then you can rank them. You can also, the dashboard that I was showing in the app, that can be developed in a different way, the recommendation section. And you can say that these are the top factors, and the ranked factors of recommendation. So definitely is something that can be developed further. Where do you obtain the industry benchmarks for attrition? So yeah, good question. So how do you go about doing that is, um, certain companies like Hayes Group, what they do is they collect data from different companies, and companies opt for those analysis because they do a salary benchmarking exercise for their jobs. So for example, if in my company Acciona is a construction and energy company, for example, and they would like to understand the data of salary of the market of other companies who are similar in offering to Acciona. So what they do is we periodically, all these companies engage with third party companies like Hayes Group, where they provide their data of their salaries, of course anonymous, not employer names, but they in return they also get analytics from Hayes Group to say similar job profiles have this kind of salary ranges in other companies, right? And so companies like Hayes Group, because they have the data of this kind of data, they also publish reports from time to time, that industry level KPIs for attrition, and there has been X amount, it has been growing periodically or whatever. So these are the kind of reports that we research online and find details on. So
All right, Sambit, I am going to cut you off there because we are just about out of time, but I want you to remind everyone, what data set were you using? Where can they find that?
yeah, so we have been using the IBM data set, which is available online publicly.
Perfect. All right. Well, thank you, Sambit. It was great having you, and thank you everyone for joining. I'm sorry we weren't able to quite answer all of your questions, but we do need to be respectful of everyone's time. So before we sign off here, tomorrow we'll be having Matthew Coatney with us. He is the Chief Information Officer at Thompson Hine LLP, and he's also an award-winning author. And he's going to be talking about his journey, his mishaps, and how taking a multidisciplinary approach led him to personal and professional success. So join us tomorrow for the T-shaped data scientist, how going deep and broad can be your secret to success. Thank you again, Sambit, and thank you again, everyone, for joining. Great questions, and we'll see you all tomorrow, hopefully.
Nice. Thank you. Thank
Bye.
you for having me.